Hello everyone, welcome back to my channel. My name is Piyush and this is day 3 video for Azure DevOps full course. In the previous video, we have looked into Azure bots and everything about it. And this particular video is all about Azure Repos. So without wasting any time, let's start the video. Okay, so let's have a quick look at the agenda item for today and the things that we'll be discussing. So I'm in my GitHub repository. By now, you should already have the link. If not, you know where to find it. So we'll be looking into the introduction of source control and Azure Repos, difference between Git and TFVC, which is Team Foundation Version Control. Then we'll configure the visual code. We'll show the steps of cloning the repo with the help of Azure Repos, commit the changes, reviewing history, working with branches, tagging a release, managing repositories, pull requests, and everything will be done with the help of a sample application code. So this application code we already generated with the help of Azure Demo Generator app in the previous video. So feel free to check out that prerequisite step if you haven't done that. And let's start with the first one, which is introduction to source control. What exactly is Azure Repos? So Azure Repos is a source control system which helps you track the changes, which helps you maintain the code base when you work in a team or even for your personal project. It has a lot of benefits. When a user commit a code change, it basically instruct the Azure repo to take the code snapshot. Like it maintains the older version, newer version, and basically all the history of the particular code base, and everything is maintained in the version control system so that you can roll back the changes, you can review the changes before merging the code if you are a repository maintainer, and it helps you keep organized, it helps you collaborate with other team members. It has a lot of benefits. This is really important because if there was no version control system, then in early days what developers used to do, they used to keep their code in a shared drive, and it was hard to collaborate, it was hard to make any changes, and there was a lot of complexity with that process. So that's why the version control system was introduced. So over here, you can see a sample commit history, like who made the changes, what changes were made with the commit ID and everything. So you can roll back to any particular commit ID as well. And there were, a merge request, which was approved by someone and so on. So everything is well maintained and everything is there for review, and it helps you keep organized. Now the next topic is Git versus TFVC. So Azure Repos, as you can see, supports two type of version control. One is TFVC, which is a centralized version control system. Another one is Git, which is a distributed version control system. So Git is one of the most popular version control system these days. All the companies, be it a startup, a mid-scale organization, or a large-scale enterprise, and even people use it for personal project, open source projects, and so on. So Git is really popular source control system these days, and it has a lot of benefits. For example, multiple developers can work on a single code base, and they can basically clone the entire code repository, and they can code the entire code repository along with all the history, all the versions locally, and make the changes locally, working offline or remotely, and then sync the changes to the main server. And you can use different type of Git clients, such as Git client for Windows, VSCode, VS Studio, and there are a lot more. And to host your code repositories or your code base, you need a repository hosting service. So these services could be, either GitHub or GitLab, Bitbucket, or Azure Repos. So which is what we are discussing here. Then the next one is TFVC, which is Team Foundation Version Control. Git was distributed version control. The Team Foundation version control is a centralized version control. That means the developer can only download one version locally, make the changes, and all the history and rest of the versions will be maintained in the central server itself. Right? So there is a huge difference between how these two work. That is why people are moving away from TFVC and migrating their code base to Git based version control system. Some example of the repository hosting that it supports are Perforce or SVN, organizations used to work on these type of version control before. And it had a mechanism of file locking. Like if I am about to make a change to a file, I have to lock that file, make the changes, and then push the code so that no one else can make the change to that particular file. And it was basically really hard to work. There were a lot of issues while resolving the conflict, and it is not really a recommended approach nowadays, but in some scenarios people still use it based on their requirements. In this particular video, we'll be focusing on the Git based version control. Alright, so as part of the first step, I'll just configure my VS Code, which is the Git client that I'll be using for this demo. So I'll open the VS Code, but feel free to use any Git client of your choice. Okay, so I'll go over here and go to terminal, open a new terminal, and I'll switch it to git bash. Okay, then I'll run this command, git config global credential helper win cred to save my credentials. And then I'll run the command git config global user.name and my name, and then user.email, my email. Now I'll go back to my browser and open dev.azure.com to log into my Azure DevOps. I'll go to this particular project, Parts Unlimited, that was generated with the prerequisite step that we did in the last demo. So I'll open that. And now I'll go to repos from the left side. So I am in my Azure repos, and on the right side it says clone. Click over there. And now I have two options. One is to generate the Git credential or copy the complete repository URL from here, or I can directly clone it into an IDE. VS Code is the default IDE, but if you click the drop down, there are a lot of other options that you can choose from. So let me just select clone in VS Code. I'll click over there and it will prompt you to open the VS Code. Click on that. Okay, so let me create a new folder over here. Code, select, and then it is now cloning the Git repository over there. Before that, it will ask me to log into my Microsoft account to authenticate myself. So let me do that. And from the next time, it won't ask you the user credentials because your login details will be saved to WinCred, the command that we set earlier. So this is just a one-time thing. Okay, I have entered the code, sign in. Okay, add to workspace. Okay, so it has added this project over here with everything as part of the source code. So let me remove these ones. I don't need these two folders. Okay. All right. So our Parts Unlimited project has been cloned successfully. Okay, so let's try to make any changes to the source code and see how we can commit the changes. So let me expand this and open the source code. Maybe go to a folder, let's say migration, and inside that there are multiple files. So we can make a simple change, maybe, just add a comment. So let's open this file. And over here, let's add a comment, first change. Okay. And save the file, Control S. Now, once you save the file, it will be visible over here in the source control. Is ready to be staged. Staged is not, it's not committed to the remote repository yet. When we make the changes, it will be stored locally now. And after we sync it to the remote repository, then it will be published to the remote repository. So now over here, enter a commit message, my first change, so that other people who are contributing along with me in this project will have the idea what this change is about. Right? This is just a dummy change. That's why it won't give you much details, but just to give you an example, and then commit the change. And it says, would you like to stage all your changes and commit them directly? Let's click on always. Okay. Now the changes has been staged. To sync your changes, you can click over here where it says sync changes, or at the bottom where there is a sync button visible, you can commit it to that, and it will commit to the origin master branch, which is the remote repository. Right, so let's click over here to sync the changes. Now it says 0 over here. That means changes has been committed and there is nothing visible over here. So let's go back to our Azure repo and review the changes. So over here, if you go to commits, the latest commit should be visible on the top, which is this one, my first change. And it has the change that I made, right? And in this file, the change was made. The line that was changed is highlighted in a green color. If there was something deleted, it would have been red color over here. But now that I've added the line, it is represented in the green color. All right. And you go back, and this is the commit history, what changes were made along with the comment and the commit ID. If you want, if you can click on that and you can view the changes. So these files were deleted and the entire content highlighted in red. These were also the deleted part. So that's the commit history. Now let me show you the difference between staging area and the remote repository, how we can manage those commits. So I'll go back to my visual control, VSCode. I'll make another change. Let's call it my second change. Save the file and open another file and make another change. It says my third change. Right. So now I have made the changes in 2 files. So if I go back to the source control, these are the 2 pending changes. Let's stage only one and let's try to sync. So if I click over there where in front of a file, there is a plus symbol. So by clicking on that, we'll stage the change. So I have staged the change and now it says stage changes and changes. So these ones, the changes in the category.cs will still be the local changes. It will not be committed to the remote server because we have not staged it. Right. And this one we have staged it already. So what next you can do is you can click on these 3 dots, okay, and then go to commit and then commit staged. This is what we need to do. Click over there. I forgot to add the commit message. So let me add over here. Change to, save the file, close it. And now you will see one change has been committed already to the remote server. Another one is still over here. So let's review. But we have not synced it yet. So click over here to sync the change. All right, it's been synced. We go back and let me just refresh this page. Now I only see my change 2 and change 3 was not committed. Okay, now if you want to review the changes that was done locally, so you can click on the file and it will highlight the changes that was done. So it says in front of line 8, it says plus, and then this line is highlighted in green color. The similar way it was highlighted over there in the Azure Repos. So if we go back to Azure Repos, so if you want to download the file that was there before this change, you can go to the previous commit, which is this one, browse the files, and let's expand this, go to source, expand this, models, and then car item. Inside that, the change is not here, right? So you can download this file by clicking over here and download. Okay, so let's understand the concept of branches. So you have an remote repository in the Azure Repos, and that remote repository has a branch which is master. So this is the remote branch, different from the local branch. When you clone the repository over here in the VS Code, there was a default branch created for you. That branch is master. Now this is the local branch, different from the remote branch. When you make the changes in your local branch, commit it, and then it will be synced to the origin master branch, which is a remote branch, right? So you make the changes over here, right? And then you sync it to the remote branch. And the same way we can have multiple branches for the same code repository, even though they are using the same code base, but the copies will be maintained differently. Let's say you create a new branch, which is dev branch, and it's been created from the master branch, right? So let's say master branch will have two files with 100 lines, right? And then you create a dev branch from the master branch. This dev branch will have the same code, two files of 100 lines. Now, when you make any changes in this branch over here, in the dev branch, in any of those files, those changes will not be reflected in the master branch. So this is a separate copy. Okay. So when you make the changes in dev branch and when you sync it remotely with the remote dev branch, those changes will be reflected only in the dev branch, right? So these two branches are separate from each other, even though if they are on the same code repository. It has a lot of benefits. Now, multiple developers can work on their separate branch without impacting the existing code base. So you can create a feature branch or you can create your own branch, make your changes, and then create a pull request to merge your code to the main branch. We'll see the pull request in the later section of this video, but for now, just understand the concept of branches, how they are different from each other, and the difference between local and remote branch. Okay, now let's go back to our VS Code. And over here on the bottom left side where it says master, click over there. Now select the option where it says create a new branch from master. So this master is the local master branch. The origin master is the remote master branch. The difference between those two will be with the naming conventions as well. Right, so I'll select this one and provide a branch name. Let's call it dev and hit enter. Okay, so over here you will see the branch has been created dev and the branch has been switched as well. Now whatever changes I'll be doing locally in the dev branch because this is what I've selected. You can change the branch by clicking over here and go back to master, right? So I'll switch back to dev. Okay, now if I go back and go to branches over here, so these are all the branches that I have, and I don't have the dev branch yet, right? But if I go back and click on sync, it will not just sync the code, it sync the branches as well. So I'll click that and it is synchronizing the changes. And let's go back and hit refresh. Now I can see a dev branch has been created as well, and it was authored by my name. So this is what we wanted to check. Okay, now on the right side, on the three dots of this particular branch, click over here and click on delete branch to delete the remote branch. Yes, delete. Now the branch has been deleted from here, but if we go back, let's hit refresh and click over here. It still says dev branch and origin dev branch, even though we deleted the remote branch, but it has not been synced over here. So that is why it is showing both the branch. So what you can do is you can open the command palette, Control Shift P, and type git delete branch. And now you only see the master branch because you already there in the dev branch. So let's change the branch from dev to master first. This is the local master. Now again, Control Shift P and git delete branch. Now you will see the dev branch. Select this and so now if you click over here, now you don't see the dev branch, but you still see the origin dev, the remote dev branch. So for that, you have to prune the dev branch so that the unused remote branch will be removed from here. So for that, the command again, Control Shift P and then git fetch prune this one so that it will fetch the latest remote branch and delete the unused branch. Right. So this one. And if you click over here again, now you only see local master and remote master, and dev has been gone now. It's been pruned remotely and we deleted it locally. If you want to check what exactly it did, so maybe you can open the terminal window from here, new terminal, and go to output. If you don't see anything over here, you go over here where it says task and change it to Git, so that it will show you the logs. Git. Okay. Now it says, you scroll up, it will show you the history, what it did. Like it did the git fetch and prune the unused branches. It deleted the origin dev when the prune command was ran. Right, so this is how you can keep track of everything that's been done with every command that you ran. Now let's say how you can manage the branches from Azure Repos like the other way around. Earlier we did it from VS Code and then synced it to Azure Repos. Let's see how it works the other way. So you go to branches, okay, and then click over here, new branch, give it a name. Let's call it release, and based on master, you can select a work item to link with it or just leave it blank for now and hit create. Okay, the release branch has been created over here. Now let's go back to VS Code, open the command palette, and this time we don't need to prune the branches. Just git fetch should be more than enough. So just select git fetch and click over here. And now it says origin release. So the release branch is now been fetched. We can see the release branch. And if you want to create the similar branch locally as well, so again select it and go to the release branch, origin release. Once you select, it will create a local branch as well with the name release. So now you see the release local as well as the release remote branch. By the way, if the branch was deleted from the remote Git repository, you can restore it as well. So let's go back and let's say we delete this release command, delete branch, delete. Now search the branch over here, release. Okay, it has to be exact. That means even the letter casing as well. The R was in uppercase, so it's visible over here in the deleted branches section. On the right side, click on more options and restore branch. Okay, the branch has been restored. Now if you go back, you see the branches here. But you should know the exact name of the branch. Without that, you cannot restore it. You can also lock a branch to make it read only so that no changes are being made to that branch. It usually happens in case of a code freeze. Usually during the end of the year, there is a code freeze and people are not allowed to make any changes to the code base. So then in that case, you can basically lock the branch. So let's say this branch we have to lock. So again, click on more options and then you will see an option which says lock. Now click on that and the branch has been locked. You cannot make any new changes. To unlock it, again, click over there and click unlock. As simple as that. Now the next part is tags. So you see option over here which says tags. Click over there. And we already have one tag to this particular commit ID. That means this particular release is finalized after this commit has been made. So we can create the new tags as well. We can make the changes to the existing tag and it can be done for a variety of reasons. So let's create a new tag and name it, let's call it 1.1 based on master, and let's add some description, release it now. Okay, hit create. So this is based on the latest master commit ID because we have set it as that. And if you click on that, it should have the changes that was done, my first change and my second change. That means this is now ready to be released and it has been tagged properly. Okay, so to create a new repo, you go over here and where it says plus in front of the project, click over there and create new repository. So let's call it test and add a readme file, and then you can also select the option whether it should be a Git repository or a TFVC. We have already seen the differences. We have already seen the difference between those two. So let's select as Git and hit create. And you can switch between the repositories by going over here, and the other options are available. You can create new, you can import as well. Okay, so click over here, click on manage repositories, and then these three, and you can rename it or delete it. Let me delete it, enter the name and delete. The repository has been deleted, and now I'm back. So now we are at the last topic, which is pull request. So pull request is a way of controlling what code can be merged into your main branch, right? So because we are collaborating with multiple other people, multiple other developers, so we need to make sure that the code that is getting merged into your main branch or master branch is being tested properly, is being reviewed by someone before it's merged into the actual code base. So this is why we need to have a pull request. So whoever is making the changes, create a branch and make the changes in that particular branch, and then create a pull request to merge the branch into the master branch. Someone who is a repository maintainer would then review that pull request, review the code and the file changes in that particular pull request, and either approve the request, decline the request, or approve with suggested changes, and basically provide the feedback whether it can be done or not done. Right. So this is why we need pull request. So if you go over here, um, the last topic where it says pull request, currently there are no pull request because we have not created any. Let's go back to our VS Code. Okay. We already have one change that was not staged before. So let's stage this one. Let's enter the comment pull request demo and sync the changes from here. Create new pull request. Select a source branch, which is release into master. Okay, pull request demo. Add a reviewer, add myself. Let's add work item as well. Let's select this one as a customer. I want to view new tutorial. Okay, and create. Okay, now you can see all your changes over here, like files that were changed. So file is my third change, the file that we just pushed to the release branch. So it's added in the pull request, and you can go to the updates tab to see the commit history based on this commits. And finally, as a reviewer, you can approve the changes or approve with suggestion or reject it, wait for the author. These are the different options. So let's say I have verified everything looks good. I can just go and approve it so that I have seen everything. It looks good to me. So I can maybe go to overview tab, add a comment. Let's call it LGTM. Looks good to me. And I have already approved it. So comment, and we need to, even though we approved it, we need to complete the pull request. So let's click over here, and then we have different merge type. So we basically merge this branch into the main branch, and after that we also complete the associated work item. So the work item that we attach to the pull request, it will be marked as done once this is merged, and that's it. And then complete the merge. Okay, there is no merge conflict. That means no other developer were working on the same copy of the file, and we are good to see that further. Now let's go back to repos in the file src, this one, and models alt item. No, this was category. And here is my change. That means it's been merged into the master branch. Pull request was completed. So this is how we work with the pull request. Azure repos also provide you flexibility to enhance the security of your branches with branch policies and with pull request policies. So let's have a look at that. First, go to project settings from here, and then there'll be a repository setting. You go down over here. Okay, so this is the only repository that we have. So click on the repository and then go to repositories policies. And over here, there are some repository settings like whether users can fork this repository or not. This is enabled by default. You can disable it if you don't want that. Everything. So these settings over here are at the repository level. But if you can go to policies and scroll down, there are branch policies. That means you can apply strict policies on your branches as well. For example, let's say you want to secure your master branch because it is where your production code resides, right? So if you click on that master branch, there are some branch policies that you can set. For example, require a minimum number of reviewers. You should have your PR reviewed by at least 2 reviewers, only then it will be merged to master. So you can select as 2. And if you want, allow requester to approve their own changes if the requester is also a repository maintainer. So disable this for now. And then you can also enable this option, check for linked work item. That means the pull request will not be completed even if there is one work item which is not been completed. So it will block that PR merge as well. And if you can scroll down, you see automatically include reviewers. Click on that and it will add a default reviewer to each of the pull requests. So let me add myself required, and you can leave it blank to include the specified you can leave it blank to include myself on every pull request, or you can just add the folder path if you want certain folders to be only approved by this particular reviewer. And then hit save and the changes will be done. Thank you so much guys for watching the video till now. I hope you have learned something out of it. Make sure you do the hands-on, else you will forget the things that we have just seen. So try to do the hands-on, try to implement the projects that will be there in the upcoming videos as well. And let me know if you face any issue in understanding any of the concept. I will see you tomorrow with the next video. Till then, take care and have a good day.